These next two examples get a little bit trickier because we have variables on both sides. But in these two examples, let's just keep it positive. And what I mean the coefficient in front of the variable. Switch back to black. All right, so just preemptively what I'm going to do is I'm going to put my inequality. That's kind of a little sloppy. There you go. Not perfect, but it'll do. And I want to isolate the variables on one side. So if I can just start out with the variables, okay? I want to get all of the variables onto one side, and if I want to keep it positive, what I'll need to do is I'll need to subtract 8y from both sides, because if I subtract 9y from both sides, 8y minus 9y, that's going to be negative y. Now tomorrow I'm going to give you a little bit of a strategy to help you cope when there is a negative in front of the variable, but let's just keep it positive today. So I'm going to subtract 8y from both sides. And it's going to become 9y minus 8y is simply y minus 14. 8y minus 8y is just 0, so all that's left over on this is positive 3. Now I can say plus 3, or I can just put 3 there, because I know that the positive is implied in front of just a simple 3. Now I want to get the y all by itself, so 14 is subtracted from it, so I want to add 14 to both sides. And when I say add 14 to both sides, I mean both sides of the inequality, so the left-hand side of the inequality and the right-hand side of the inequality. I'm going to write in my sign here. Y minus 14 plus 14 is simply y. 3 plus 14 is 17. And I'm going to put down my number line extending to infinity in both directions, negative infinity and positive infinity. And I'm going to put my critical number here, which is 17. That's the number that we're dealing with here. And I'm going to put an open dot. Now y is less than 17, so my solution is actually going to be going in this direction. I did the solution in black, but you can clearly see that the solution is on this side versus that side. All right, let's move on to the next one. Oh, and again, remember, no verification, because then we would have to verify 16, 16.1, 16.01, 16.0001, and like all of the numbers like that, and all of the irrational numbers too. It's, yeah, so don't worry about verifying when it comes to inequalities. Phew. So if we want to go with our mantra today, which is keep it positive, which should be your mantra every day, by the way, 3r and 2r. So I'm going to subtract 2r from both sides. Because if I would, 24, that's funny. If I were to subtract 3r from both sides, it would be negative r on this side. And remember, we want to keep it positive. So 2r minus 2r is 0 plus 14. So the right-hand side is simply going to be 14. 3r minus 2r is simply r minus 17. Very similar setup to the previous question here. I'm going to add 17 to both sides. So on this side, r minus 17 plus 17 is going to be just r, is greater than or equal to 14 plus 17 is 31. So I'm going to have my number line here extending in all both directions, negative and positive infinity. My critical number here is going to be 31. And when I say critical number, I'm just saying the number that we're dealing with. R is greater than 31. That's our special number. And I'm going to use a closed dot. Just for the heck of it, let's change the color. So r is greater than 31, so my answer, my solution, extends to the right. So let's just look at this one right here, an example that we must be careful around. X is greater, 7, see that's exactly how us mathematicians are programmed. 7 is greater than X. If we were to draw this on a number line, first things first, 7 is our critical number, and we're going to use an open dot. If we were to follow what some people do and just follow the direction of the inequality, we would say that the solution goes off in this direction. But remember, the X is on the right hand side, which is uncommon. Okay, we usually read that the variables are on the left hand side. Okay, but if we say 7 is greater than X, that means that 7 is bigger than the solution. So that means that the solution would be here and here and here. It would not be here. So if we just mindlessly follow the direction of the inequality, we're going to get a question like this incorrect. So either what we could do is this is the exact same thing as X is less than or equal to 7. Okay, because the arrow is still smallest, or the inequality is still smallest towards the X. And then in this way we can use our rule when it comes to graphing inequalities, which is put a 7 here, put a solid dot here because of the less than or equal to, and follow the direction that the inequality is pointing. So in summary, it is always easiest to keep coefficients, that's just my short form for coefficients, of variables positive and solving for inequalities follow the same steps as solving equations. So remember, equations have equal signs. You must plot solutions on number lines.